All right. Well, we're now on problem number 5 on page 408. And they have this little drawing here. And it says, on the disk shown above, a player spins the arrow. I drew my little arrow here, this little blue arrow. A player spins the arrow twice. The fraction a over b is formed. A over b is formed, where a is the number of the sector where the arrow stops after the first spin. So there's the first spin. First spin. First spin. And b is the number of the sector where the arrow stops at the second spin. Second spin. On every spin, each of the numbered sectors has an equal probability of being the sector on which the arrow stops. What is the probability that the fraction a over b is greater than 1? So they want to know the probability that a over b is greater than 1. Well, the first thing you need to realize is this is just, a random number generator. We could have been the probability that any number between 1 and 6 is equal. So this could just be, a roll of a 6-sided die and saying, well, if I roll a 6-sided die twice, what are the odds, what's the probability that the first roll is going to be larger than the second roll, right? Because in order for this fraction to be greater than 1, the numerator has to be greater than the denominator, right? Or you could just take a over b greater than 1 and multiply both sides by b, and that's the same thing as the probability that a is greater than b. So what we can do is we can set up a little table, and we could say, well, what's the probability of getting each of these numbers on the first roll? And then given that probability, or given that you got, let's say a 2 on the first roll, what are the odds that the second roll is going to be less than the first roll, right? So let's say, or spin. So let's say spin. Let's call this spin. 1, 2, 3, 4, 5, 6. And what's the probability of getting each of these spins? Well, the probability on the first time, right? Probability of spin, so we call that spin 1. I'm just making up notation as I go, but hopefully this makes sense to you. So the probability of getting any one of these is 1/6, right? So we can just say it's 1/6, 1/6, 1/6, right? They all have an equal probability of happening. 1/6, right? Now we have to say, now given each of these, what's the probability that your spin 2, your second spin, is going to be less than, right? The second spin has to be less than the first spin, right? This is the second spin. B. I could have just written A here. Probability of A. That'll probably make more sense to you. And then we want to know the probability that the second spin, B, is less than A. Well, if I got a 1 the first time, what's the probability that I get a number less than 1 out of these? Well, is there any number less than 1? There's 1, but that's not even less than 1. That's equal to 1. So there's a 0 chance that I get a number less than 1, right? Because there is no number less than 1 that I can get. If I got a 2, well, there's only one number less than 1 out of the 6, right? That's 1. So there's a 1/6 chance. A 3, if I got a 3 on the first spin, I can only get a 1 or a 2 on the second spin, right? So that's a 2/6 chance. 2/6. If I got a 4, I could get a 1, 2, or a 3. That's a 3/6. I think you see the pattern here. There's a 4/6 chance of getting something less than 5, and there's a 5/6 chance of getting something less than 6. And so, what's the combined probability now for each of this scenario? So what is the probability that I get a 1 and then I get something less than 1? Well, you just have to multiply these probabilities. So that's a 0. What's the probability that I get a 2 and then something less than 2? It's 1/6 times 1/6, which is 1/36. Probability I get a 3 and then something less than 3, multiply them. It's 2/36. I think you see the pattern here again. 3/36, 4/36, and then 5/36. 5/36 is the probability I get a 6 and then something less than a 6. So in general, the probability that I get my first spin is greater than my second spin is going to be the sum of these probabilities, right? Because it can be any one of these scenarios would work, would satisfy A being greater than B. So I just add up these probabilities. So let's see, the denominator for all of them is 36. I mean, we could say this is 0 over 36, right? So it's essentially over 36, 1 plus 2 plus 3 plus 4 plus 5. Now let me add carefully because this is where I historically mess up my problems. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. So that equals 15 over 36. And that is choice A. Move on to the next problem. Image, clear image, invert colors. Which of the following, we're on problem number 6. Which of the following tables shows a relationship in which W is proportional to X? Alright, so let's just write them all out. So choice A, so if we have W, X, so they have 1, 3, 2, 4, 3, 5. So W is proportional to X. Well, that also means that X is going to be proportional to W, right? So in this case, X is 3 times, so here we have times 3 is equal to 3. Here we have times 2, and here we have times 5/3. So we're multiplying by a different factor every time. So W is not proportional to X, and X is not proportional to W. I'm just trying to figure out what do I have to multiply W by to get X, or what do I have to multiply X by to get W. And they all have to be the same in order for these two variables to be proportional. So choice A is not right. Choice B, W, X. 3, 9. So I multiplied, well, let's see what I'm doing. 3, 9, 4, 16, 5, 25. It looks like in every scenario here, we squared W to get X, or W is the square root of X, but they're not proportional, because here we multiplied by 3, here we multiplied by 4, and here we multiplied by 5. So once again, it's not going to be choice B. C, I will change colors for variety. Oh, let me change this brown. C, W, X, 5, 10. So I multiplied by 2. Right, this is what I'm multiplying by. It's not 10 times 2. 6 to 18. 6 to 18. I multiplied by 3. I already know this is wrong, right? I multiplied by 2 different factors. It's not choice C. Choice D. W. They probably did it one of the later choices just to make sure we do a lot of work. Choice D is 7 to 21. I multiplied by 3 to do that. 8 to 24 times 3 looks good so far. 9 to 27 multiplied by 3. So in every case, I multiplied by the same factor. So W is proportional to X, or proportionate to X, and X is proportionate to W. So D is our choice. I will see you in the next video. And we don't have to worry about E because we know that D is our choice. I'll see you soon.